that we're going to cover because there are 4 different ways we can change a graph. So we can stretch it vertically, and that's the amplitude, so that affects A. B is our second letter we're going to talk about today, and B is in front of X. And in our case, X, the x-axis represents the angles. So now we're going to affect the x-axis or the angles and how those would be stretched. So A stretches vertically with the amplitude. The B is now going to be stretching the graph horizontally. And then tomorrow we'll learn about C and probably D as well. D is the easiest one. C is, I think, the hardest one. But those two shift the graph. So the first 2 days are stretching it both ways. And then the other 2 letters are shifting it and moving it. So it's easier to move something up and down. It's always easier to do things with Y, because Y is just a regular number. X is an angle. And it's a little harder to try and think about how an angle stretches or how angles can shrink. So we have sine and cosine. Y equals A sine BX and Y equals A cosine BX. And just a little reminder, we talked about this yesterday, but we said 1 cycle of the graph, there we go, is 1 rotation around the unit circle. And a rotation around the unit circle starts at angle 0, and then it spins all the way around and it goes to 2 pi. We're just taking that unit circle and like flattening it out on the x-axis. So a cycle around the unit circle, or through our horizontal graph now, still starts at 0, and it usually goes to 2 pi. Except that 2 pi is going to be affected by the b value with x. So that 2 pi changes by that factor of b. And we'll be dividing by that factor of b, the number in front of x. So instead of it being the typical 2 pi distance, I might shrink that distance because I'm dividing by 2. Or if we're dividing by a half, that distance might stretch. Because when you divide by a fraction, you end up multiplying by the reciprocal, and the number actually gets bigger. So always starting at 0, because the unit circle starts at 0, but the end of it might change based off of the value that we're multiplying by, that b value. So that b value is also associated with the period of the graph, the distance of the graph, and that's why that 2 pi is there as well. So 2 pi represents a couple things. It's 1 rotation around the unit circle. It's also representing the period or the length of the graph. And then that b value is affecting it. So here it says, if the b value is between 0 and 1, if it's a fraction, the period actually becomes bigger. It's going to be greater than 2 pi, and we call that a horizontal stretch. So we have the vertical stretch and the vertical shrink. So now it's going to stretch horizontally if the number is between 0 and 1, because we're going to change our period. It's going to make it larger. Or if the b value is greater than 1, then our period would be less than 2 pi. Because again, you're dividing by that b value. So if I divide by a number greater than 1, my fraction is going to get smaller, or my period is going to get smaller. So we call that a horizontal shrink. The other thing, sometimes you're going to see negative angles. Anytime there's a negative inside with the angle, the negative angle property, identity, that we talked about back in 4.2, so it was a little while ago. But because the sine is an odd function, when you have a negative angle, odd functions become negative. So we don't make an angle negative. Instead, we pull that negative sign out in front of the function sign. And that's because the sine is an odd function. And odd functions change from being positive to negative in the opposite quadrants. Odd functions are opposites in a plus versus a minus. Odd functions are opposites in the quadrant they're in, and they have that original symmetry. However, with cosine, cosine is an even function. So if your angle is negative for cosine, it really is the same thing as a positive angle for x. And we looked at that with triangles, and that's because x, when you make the angle negative, you're still on the positive x-axis. So that's why cosine stays positive, since cosine is directly related with x. So even functions remain the same, whether I have a negative angle or a positive angle. Odd functions are opposite. So we'll never keep a negative angle. We just pull that negative outside when we're dealing with sine. Or it's just going to be the same as the positive angle. So we'll run into that just every once in a while. We'll look at examples. So there are two examples that we're going to work through today. The first one, yeah, these are both dealing with sine instead of cosine. And then I'm going to start one of the homework problems with you, and you'll have some time to start graphing in class today as well. So there's 6 graphs that you'll do. The end of the homework are 6 graphs. The first part of the homework is more just like explaining what the pieces do to the graph. So if you have a number in front, is it a vertical stretch? Is it a vertical shrink? Or if we have a number with the x, is that a horizontal stretch or a horizontal shrink? So that's the 11 to 27 odd, and then you'll have the rest of it just graphing. So we're going to start kind of like taking pieces of this and trying to interpret what it means. We have y equals the sine of x over 2. So we have 2 letters that we're now introducing. Yesterday was A, today is B. What would the amplitude be in this problem? A 1. Because the number in front of sine is 1. So, Dylan, will this graph stretch vertically? No. Because the typical amplitude is 1. So it's not going to stretch vertically. So we don't have to worry about that vertical stretch. Let's talk about the B value. What number is with x? I heard a 1. I see a 2. What number is in front of x? A 1. Josh, what number is with x? 1/2. I could also write this as the sine of 1/2 times x. That means the same thing. So if I have x divided by 2, I'm taking x and cutting it in half. Or it's the same thing as taking half of x. They mean the same exact thing. So the b value is 1/2. So anytime you're dividing that x, there's really a number in front of that x. It is a fraction of 1/2. So we have to decide how this graph is affecting our period. And the period is found by taking 2 pi and dividing it by b. Because the typical distance is 2 pi around the unit circle. And now that b value is going to change that distance. So if we calculate that, we're going to find our new period, because it's going to change. What is 2 pi divided by 1/2? 4 pi. Remember, you're multiplying by the reciprocal. So if I'm dividing by 1/2, I'm really multiplying by 2 over 1. So again, just a little reminder up above, if my b value is between 0 and 1, we should be stretching the graph. So even though the x is being divided by 1/2, it's actually stretching our period. It's doubling the length of it. So our period is now 4 pi. That means it's going to start at 0, and it's going to pass 2 pi, and it's going to go all the way to 4 pi. So we have to be able to calculate a couple things when we have x. It's not just as directly as like, hey, just take that 2 pi and multiply all my x values by it. We have things that we've been working on yesterday called key points. How many key points do we usually have? 5. How many quadrants are in the unit circle? 4. 5 points divide your graph into 4 sections. So the way we're going to calculate our key points is to take our period and divide it by 4. So we're still going to have 5 points, but really there's 4 sections of the graph. So to get those 4 equal sections, everything is equal. Think of the quadrants. Each one is a quarter of the circle. That's why we're dividing it by 4. So this would be pi because the period cut in fourths is pi. This number is what we're going to be counting by for my angles. So my angle isn't going to be 0, and then pi over 2, and then pi, and then 3 pi over 2, and 2 pi anymore. The angles are going to be created by using pi. So that would be the difference from yesterday with the amplitude, just taking y and multiplying y by the amplitude. We actually have to like create our number to count with to get our angles. So we have, let's see, we're working with signs. I'm going to write our ordered pairs down here. We still start with angle 0, because that isn't changing. I'm still at angle 0. I'm going to ignore the y for now. But my next angle is no longer up at pi over 2 on the unit circle, because now we're stretching this graph. and it's now at pi. So this key point is how you're getting your next angle, because we need to make sure everything is quartered or divided into fourths to still kind of represent that circle. So then, Colin, the next angle would be 2 pi. So we're increasing by the same increment. That's what that key point value does. It tells us what to increase by to get to the next value. And then, Dylan, we would have 3 pi. And finally, the last point, because I need 5 of them, is 4 pi. That last point should be the distance of your period. Usually it's 2 pi, but now we're stretching it. So we're going up to 4 pi. Question. Should I keep this in?
Perhaps.
Always an excuse for Sam. All right, so any questions with getting that x value and a new angle? So then if we are dealing with sine, what would the first y value be for sine? The y isn't changing. Emma? It is 0. So even though I went to pi, my y value still isn't changing. So Emma, the second y value is typically, say again, a 1. And then the third y value, the fourth y value, and then the last y value. So the y's aren't changing. And the reason the y's aren't changing is because this x really goes in here. And it really still is x over 2. My next x is 2 pi. Well, 2 pi over 2 is still pi. So that's why your y values aren't changing. They still have that same rotation. So, question, yeah.
So if it was like sine of x, but sine was over 2, then would you change the y?
Yes, exactly, yeah. You usually wouldn't see it like that, but yes, if it was divided by 2, that 2 is 1/2 and then the sine of x, yes. If all of it's divided by 2. Nice. Generally, they're not going to write it like that, because it is a little misleading, but that is exactly what it means. Other questions? So we're going to graph this. Unfortunately, sometimes graphing, you don't actually see the horizontal stretch, because we only have so much space on a graph. So the only way we can physically see the stretch is by labeling it, and that's why you're asked to label your graphs. So I'm still going to go over 3, and I'm going to now call that pi, because my first angle is pi. So we physically won't see an actual stretch of the graph, but we can at least look at the labels and know that it's stretching by the angles that it's labeled by. So we're still using that distance of 3 and ending at 4 pi. That's a little sloppy. And then we could still go up the same, up 3 more. You can always count with the y-axis as you see fits to your problem. If you need to count by 2s, you can count by 2s. And then plot the 5 points. Remember, sine is the one that starts in the middle, and it goes up to its hill and down to its valley. There is no stretch in this graph because the number in front was just a 1. Questions? So it really does stretch, because my old graph would have ended at 2 pi, and it really has past 2 pi because it's kind of double the length of it. We're going to try another one. It's still graphing sine. We're going to see if we can kind of do the same thought process. So the only difference is we have a 3 in front of the x instead of we're dividing by the 2. And just to change it up, let's just put a 2 two in front there, just so we can see one with both things happening. Be a little daring here. Throw in a two. I know, Carrie, right? So, Carrie, the A value or the amplitude is 2. So we're stretching this vertically because it's bigger than 2. So when the amplitude is bigger than 1, that 2 value is stretching it vertically. And then, Carrie, the B value is 3. So then our new distance of the graph would be 2 pi over 3. It's 2 pi over B. So we're going to calculate the key points. Before we actually look at the key points, we need to figure out what we're going to count by. And that's when you take 2 pi over 3 and cutting it into fourths. So my graph will always be cut into fourths. There are 4 quadrants in a unit circle. If you have a fraction and you're dividing it by 4, what are you really doing when you're dividing by 4? Multiplying by 1/4. So dividing by 4 is really multiplying by 1/4, just like dividing by a half was really multiplying by 2. What does that fraction become? So 2 pi over 3 times 1/4. Brenton, you know what that becomes? Yeah, so 2 pi over 12, which he said is pi over 6. I'm going to circle that. So that's what we're going to be counting by now. So we still start at angle 0. But Brenton, our second angle is now pi over 6. So you're using this number to now count by past 0. Brenton, do you know what your third angle would be? Yeah, so you're just increasing it by pi over 6 because everything needs to be equally spaced, equally increased. So you're adding pi over 6. He said 2 pi over 6. What is 2 pi over 6? Pi over 3. So we're going to place that reduced angle in the parentheses. So I would then have 3 pi over 6, just increasing by pi over 6. Garrett, what is 3 pi over 6 reduced? Pi over 2. And then one more time, if I increase by pi over 6, I'd have 4 pi over 6. And that should be your last point, which matches the period of 2 pi over 3. Questions about getting the x? So now I threw that extra number in front for the y. So I placed a 2 in there so that we had a different amplitude. This is sine. So how does the 2 change the y value of the equation, or of the ordered pair, I should say? And what's the 2 going to do to the y values? Yeah, so you're going to multiply the y value by 2. So if it's sine, the first y value is still 0. And then the second y value is now 2. And then the fourth one? And then 0. So instead of it being 1, 0, or I'm sorry, 0, 1, 0, negative 1, 0, that number just changes your y's by 2. Your last point should always match with your period. And then you're plotting the points that we have over there. So we're at 0, up at 2, down to negative 2, and back at 0. Again, make sure these graphs have that up and down motion. Hill and then the valley. So again, it really looks like the same stretch as the one above. The one above is way longer. This one is definitely shorter because it just goes to 2 pi over 3. But we physically don't see that difference because we're still using the same increments to count. Questions? So as I said, I wanted to be able to give you some time to start the graphing part of your homework. So the first part is just calculating a new period or calculating, listing the amplitude, maybe calculating the points. So we have 10 minutes. Should be able to get a couple graphs done in So, starting at number 44, 46, the two problems on the side here. 44 and 46. Is there going to be a change in the period for 44, 46? And how do you know? Emma, why not? Yeah, B is 1. So, the amplitude changes. This is 5, that one's 3/4. But the B value in front of there is a 1. So, that means the X value should remain the same. The only thing that's changing is the Y. When you go to number 47, this is exactly the one that we graphed, except it's cosine now. We graphed sine in the notes. So 47, we're graphing cosine instead of graphing sine. And then 48, right next to it, is back to sine with the 4 in front. And then the last two problems, I guess I don't. Oh, I missed those last two. I'll have to grab those last two. But that at least gives you a couple to start working on. I would like somebody to be willing to present 57 and 58. Garrett and I'm trying to get a couple more people. All right, so Emma, 57, Garrett, 58. So make sure those key points label the positive x-axis so that we can see that, yes, it really is stretching even though we physically don't see that. And I missed the last two problems, so 57 and 58 aren't on here, but they are on the same page. Most of the homework is on the page 299, the 11 to 27 that you're not graphing. And I will send out the ordered pairs to those problems